This is an overview of the endocrine system and all of the organs, glands, and hormones which are involved. We will be demonstrating this to you via paper animation. Right here, just to go over the glands first, glands and organs first. We have the brain, your pineal gland, which is just posterior to the thalamus, kind of below the corpus callosum. You have your hypothalamus, sort of in green here, kind of hard to see. You have your pituitary gland, which can be seen in red, which has both anterior, which will be on this side, and posterior sides. You have your thyroid gland, parathyroid glands, the thymus gland, pancreas, kidneys, adrenal glands, ovaries, as well as testes.
So let's begin with the pineal gland. Pineal gland in the brain secretes melatonin. And melatonin's target organ would actually be the brain itself. Melatonin serves to lower body temperature and make you drowsy. Its antagonist would be serotonin, which is currently not displayed, but it's also released by the pineal gland, and it too targets the brain, and it serves to vasoconstrict your blood vessels and increase your blood pressure. So before you go to sleep at night, melatonin will be secreted, and when you wake up in the morning, hopefully serotonin will be secreted.
Next, we have antidiuretic hormone, which is produced by the posterior side of the pituitary gland. Antidiuretic hormone, or also known as ADH, is sent through the bloodstream down to the kidney. Once ADH reaches the kidneys, water reabsorption is promoted in order to conserve water within the body, thus keeping the blood pressure higher. Back up to the posterior pituitary gland, the second hormone that it secretes is oxytocin. Oxytocin, or OT, serves two functions. One, it goes to the mammary glands, or breasts of females, to stimulate the release of milk for breastfeeding. The second thing that it does is goes all the way down to the uterus and acts on the uterine walls to promote uterine contractions during childbirth or labor. Some studies suggest that oxytocin itself also plays a role in bonding between an infant and their mother, and also in human relationships.
So next, we'll talk about growth hormone. Now, the release of growth hormone, or the inhibition of the release of growth hormone, all starts in the hypothalamus. Growth hormone releasing hormone, released by the hypothalamus, pictured in green, goes down to the anterior pituitary. From the anterior pituitary, growth hormone can be released into the body. Growth hormone does exactly what it says. It stimulates growth in almost all tissue cells, and it especially stimulates growth in the liver, bone, cartilage, muscle, and fat. Now, to inhibit the release of growth hormone, we have growth hormone inhibiting hormone, which is also known as somatostatin. And it's also released by the hypothalamus onto the anterior pituitary. Once somatostatin is released, growth hormone release is inhibited.
Back up to the hypothalamus, we also have prolactin releasing hormone. Prolactin releasing hormone is secreted by the hypothalamus down to the anterior pituitary gland, which causes the release of prolactin. Prolactin, released by the anterior pituitary gland, travels through the bloodstream to the mammary glands and promotes the production of milk, or milk synthesis, and prepares the body to lactate during pregnancy. Now, we also have prolactin inhibiting hormone, which is also secreted by the hypothalamus, travels down to the anterior pituitary gland, and this time, instead of causing the release of prolactin, it would stop that from happening and keep prolactin from being produced.
Continuing on with the hypothalamus, we have corticotropin releasing hormone. Released by the hypothalamus down to the anterior pituitary, it stimulates the release of adrenocorticotropic hormone. An adrenocorticotropic hormone travels all the way down to the adrenal glands, and in particular stimulates the release of hormones in the adrenal cortex. Two hormones that we're going to focus on are cortisol and aldosterone. Now, cortisol is released by the adrenal cortex, in particular the zona musculata, and it targets most organs for the breakdown of fat and protein. It's considered an anti-stress or anti-inflammatory hormone. The next hormone, aldosterone, also secreted by the adrenal cortex, but in particular the zona glomerulosa, and it targets the kidneys. And its main function is the retention of sodium and water.
The hypothalamus also secretes TRH, or thyroid releasing hormone, down to the anterior pituitary gland, which stimulates the release of TSH, thyroid stimulating hormone. TSH then travels down to the thyroid gland and stimulates the production of technically three things. You have T3 and T4, but together they're known as thyroid hormone. Thyroid hormone, or T3 and T4 individually, are secreted into the bloodstream, but cannot just be transported via bloodstream. These particular hormones need to bind to transport proteins. This is because these two hormones in particular are hydrophobic. Once these, together or separate, reach the cells of the body, they pass through the membrane and stimulate an increased metabolic rate in all cells in the body, thus increasing the metabolic rate of the body overall. Now, calcitonin, which is secreted by the thyroid gland itself, or more specifically C cells within the thyroid, antagonizes the effect of PTH. So when calcitonin is secreted, like I just said, has the reverse effect of PTH. This will stimulate osteoblast activity, thus promoting calcium deposition from the bloodstream back into the bones. So calcitonin is secreted when the blood level blood is at a hypercalcemic state, and this increases bone formation and lowers that hypercalcemia in the blood back to a normal level.
Thymopoietin and thymosin are the two hormones secreted by the thymus. They both have similar functions where they trigger the lymphocytes, the T-cell lymphocytes, and they also aid in the development of other lymphatic organs.
So the hypothalamus also releases gonadotropin releasing hormone. And it will stimulate the release of luteinizing and follicle stimulating hormone in both men and women. It's an important part. So these perform different functions in men and women, though they're both produced and released by the anterior pituitary in both. So we'll start with women. Follicle-stimulating hormone will stimulate the release of estrogen in women. And in particular, estrogen will stimulate the production of follicles or ovaries. Now, luteinizing hormone in women also targets the ovaries and will stimulate ovulation. Part of what also stimulates ovulation is progesterone. So that's another hormone that the ovaries produce and release. Now, in men, when luteinizing hormone and follicle-stimulating hormone are released by the anterior pituitary, they stimulate, well, we'll start with luteinizing hormone. Luteinizing hormone will stimulate the production and release of testosterone by the testes. Testosterone's main function is to stimulate reproductive development. Follicle-stimulating hormone, produced and released by the testes in men, will stimulate androgen-binding protein, and androgen-binding protein will stimulate the production of sperm.
Now, moving down the body, let's focus on the parathyroid glands shown here around the thyroid gland. The parathyroid glands will produce PTH, or simply parathyroid hormone. This happens when the blood in the body is hypocalcemic, which means there's a low level of calcium in the blood. PTH is produced to reverse that effect by stimulating bone reabsorption. It inhibits bone deposition and reduces calcium excretion. What that means is this parathyroid hormone will stimulate osteoclasts in the bones to break down the calcium that have been deposited into the bones by osteoclasts and take that calcium and put it back into the bloodstream.
Erythropoietin is produced in the kidneys and liver, and it produces red blood cells in the red bone marrow. Insulin and glucagon are two hormones secreted by the pancreas. First, I'm going to talk about insulin. Insulin is secreted by beta cells housed in the pancreatic islets. They're produced in response to high blood glucose levels. This allows the body to use the sugars for its muscles or in the adipose tissue, or if there's extra, even in the liver.
Glucagon, the antagonist to insulin, is secreted when blood glucose is too high. And it's secreted by the alpha cells in the pancreas, and it targets in particular the liver. To stimulate the breakdown of protein and glycogen in the liver to increase blood glucose.
Norepinephrine and epinephrine are secreted by the adrenal medulla of the adrenal gland. They target most of the cells in the body, and they increase the metabolic rates of the body.
So just to recap, the endocrine system communicates with the body through hormones. It consists of glands, tissues, and cells that secrete these hormones. These organs are the sources of where hormones come from. The effects of hormones are very general and widespread. The reactions are usually slow to stimuli, and it could take seconds to days to overcome a reaction of hormone secretion. They also adapt relatively slow. Hormones go throughout the bloodstream wherever there's blood, but only target organs or cells are the ones that respond to the hormones. Target cells or organs are cells that respond to hormone stimulation due to their specific receptors for a given hormone. Today we covered some common glands and hormones that are secreted throughout the body.